Okay, good evening once more. Today we want to continue with this question paper, Computer Science 2020, paper 3. We have already answered this paper up to this point. So today we are supposed to continue with point sub 4. And that's the only thing we are going to do today. And then the rest is within your reach. So the question says, using the algorithm for a recursive binary search in figure 2, give a BL, that's programming language, procedure called bin search that takes an array, the name to search, and the bounds. You have the minimum bound and the maximum bound of the search range within the array. It then calls the recursive procedure bin search rec with matching arguments. The procedure bin search then prints the given name if found. Otherwise, the message name not found is printed. Now, note in figure 2, this is figure 2, this is figure 1, this is figure 2. In figure 2, variables found and position are global. Global in the sense that they are declared before the main function, but within the library. Okay, so what we are having here is the algorithm. The algorithm we have here, maybe let us interpret it a bit. We have Boolean is a data type, and found is a variable which is assigned to false, which means that when we start to search an item on this array, we are going to see that immediately we start from initial point where we say we have not yet found the variable or the item. Then immediately after that, the position is 1. So at position 1, we have not found the variable. I mean the item, sorry. And then here we have these variables as global variables. This global variable, global variable. So I have already written the code and I just want to explain because I noticed that when I'm writing the code, maybe I'm slow in typing and then we are wasting so much time. So I've already written the code. I will just explain each line of code interpreting from this algorithm that is on this side. So the first thing is that you have told us that these are global variables. Found and position are global variables. Even from the question, they said note that found variable and position are global variable. And here in the code, we have to use Boolean. This is Boolean, and Boolean is a data type. And in C programming, we are going to include this library, hash include stdbool.h. This library gives us access to Boolean data type. And so here are our global variables. I said global variables are variables that can be accessed within and outside of the main function. And so here we have the global variable declared as found and position. And they have data type, found has data type Boolean, that's initialized to false, and then position int initialized to 1. This is a line of code, 1, 2, already done here. Now, procedure binary search recursion. This is another section of the procedure or the function. In our code, we say using the algorithm for a recursive binary search. So this is a recursive binary search written as bin search rec. It's time for recursive binary search. We said using it in figure 2, give a BL programming language procedure called bin search that takes into array an array, the name of the name to search, and then the bounds, which can be minimum and the maximum, to search from the range within the array. So here we see that the procedure binary search recursive takes array, the name to search, the minimum and the maximum boundaries or bounds to search within the range. And here we have the data type integer bottom. They say the bottom of the array is assigned as the minimum, and then the top is assigned as the maximum, and all of them are integers. That's what I'm interpreting this section, because if you don't understand this pseudo code, it will be difficult to understand the code. And so they said if minimum is less than or equal to maximum, then the middle of the array will be equal to minimum plus maximum divided by 2, which means that if the minimum value, the bottom, is less than or equal to the maximum, which is the top, it means that we have to calculate the minimum. It's logical because if the bottom of the array, okay, is already greater than or equal to maximum, it means that the function is going to misbehave. So we said if it is less than or equal to maximum, then the midpoint, the midway gone or halfway of the array will be calculated as the minimum plus the maximum point divided by 2. Now, if the array at that middle point, because after dividing now we have the middle point, and that middle point is equal to MID. And we said if the array at that particular point, which is the middle, is equal to the name, then which means that when we divide the array, we have a certain point or an index at a particular point of that array. And then at that index, we check if that at that index, the name that we are searching for is there, then we say that we have found the name. So that's why you say found equals to true. But if, and then we return the position where we have found the name, maybe at that middle point, maybe it's at 2, at 3, then the name is found at that position. But if the array at that middle point is less than, means that it's on the left side of the array, less than the name, then we said in the right half of the range. So we are saying now that the name will be on the right side of the array. In binary search recursive, we have to call now the array, the name, and then we increment the middle point by 1 because it is less than. So if it's less than, it means that the name is not found on the left side. So we have to add +1 so that we can go to the top. We are moving up. When you add +1, you move up. When you subtract -1, you're moving down the array. Else, we move to the left side of the array to check whether the name is found there. So to go to the left side of the array now, we are going to subtract from the middle -1, and we're moving back to the bottom. That's why you see it here. Then we end if, and we also end this other if, and the procedure is gone. That is what we have been told here in this question, that using the algorithm for a recursive procedure and so on, we should be able to write a function to do that. Then they said we should also use a procedure binary search. Then we should use it to print the given name if it is found. And then if it's not found, we should print the message not found. So here is the other procedure bin search they are talking about here. They say this bin search, you have the array, name, and then the minimum and the maximum. Remember, the minimum here is the top, is the bottom, and then the maximum here is the top. So here you have min, which is the bottom, and maximum, which is the top. If it is found, okay, if found is, what is this? It should be equal to false. Then we print name not found. That's why I'm saying, but this name not found to interpret means that here we have, but if found is equal to 4, which means that we have not found anything, we then print that name was not found. But if it is not, we print the array position where the name was found. So that is everything that this point 5 it was talking about. And so we are going to go into our program now. This is a number 2, number 3 that we have already done. Number 4 already done. Number 4 already done. Okay, I think number 5 start from here. Normally this is sub 5. This is even 6. This is 6. It's supposed to be here. This is 6. Okay, this is function to recursively search for a name. So here, this is a void binary search rec. Binary search rec. I've already declared this as global variable. So void, since a procedure, it means I'm returning nothing. So we have void binary search rec. It says going to take the array, the name, the min, and the max. That's what I'm having here. You see that it takes the name, the array, the name to search, the min, and the max. That's it. And immediately say integer, and then there is bottom assigned to, or minimum assigned to bottom, and then top assigned to, maximum assigned to top. So you see that here int bottom equals to min, int top equals to max. Very simple. I just take it and put there. Now, if min is less than or equals to max, this is it here. If min is less than or equals to max, curly bracket open and close, in min will be equals to the min plus max divided by 2. This is this one. Where is it? This is it. So this line is interpreted. Then here, we are comparing because they said if the array of mate is equal to name. You see that when we are dealing with array of characters, we are going to use the the character or string function. So here we are dealing with string. That's why we use to compare string, compare this function. Array at the midpoint, comma, and then name, which means we are comparing this name with the name that is found at the middle of the array. If it is equal to 0, it means that the name is found. That's why we have found equals to true. Then the position where it is found is mid. There's something you have to note. If you are comparing something in C and it is string, you know that if the comparison is less than 0, it means that the name is not found. If it's greater than 0, it means that it is not found. But if it is equal to 0, it means that it is found. So here, they say else if we compare this name at the middle point with the name what we have entered to search and it is less than 0, means that the name is not found. We should call now the binary search rec, which is here, to check where the name is found. Because we have divided here by 2, means that the min has changed. And then we get the name, the array, the name, and then we increase. Since it is on the left side, we need to move to the right side to check whether it is there. So move up. And then if it is not found, but it is now showing that it is greater than 0, because else here means greater than 0 here. Means that it is found on the left side of the array. So that is, we move to the bottom. Now that is said and done. They now ask us to call this other function down here. so that you'll be able to print the message that name is found, name is not found. So this Z, which is bin search, so binary search, it takes into consideration the name of the array, the name we have entered to search, the min and the maximum. Now, we call the recursive procedure of the name of the array, the name we have entered to search, then our position, minimum or maximum. Now, if not found, we are here. If it is not found, if found is equal to false. In C, we interpret it as such that if not found, yesterday somebody asked a question of this equal sign, of this exclamation mark. It means that if not found, we print F, name not found. Else, name found at position. That's what they are talking about here. Our position is the name found. We now call the position plus 1 because we are starting from array start from 0. Then we have the array at that position. So that's what they say, print array at position, that it is found. That is all about the program. And then we just go to the main function to call it. So here is where I call my calling function to search for the name. So this is a variable that I've just put for the name. And then you enter the name to search. And then the user is going to enter this name. If the user enter the name, we look through now, we call our function binary search. And when we call this our function binary search, we have to pass a name that we are looking for in the array, which is already from up. These are the names here. These are the names here. So we take this name of the array, then the names or the name that the user has entered, then at position 0, that way we start from the first index here. Yeah, where is the stuff? Initially it was just, yes, this is it. Found equals to 0 means that to false means that it's equal to 0. So at that position, we have not yet found anything. That's why I put 0. Means that we have not yet found anything. Out of the 15 names, that's the size of the array. Out of the 15 names that are here, when we just start, we have not found anything at this position. We check this position, the first position, to see whether the name is there. So now I'm just going to run it. Now, when you call this function in this position, it will be reflected up here. And then when it reflected up here, this is it here. I've changed it. When it's reflected up here, when once you run this line, it will call this one. And then this one is found up here. And then it will run through all of this before it continue with this one. And when it works this one up, it will now be able to just bring a message that it is not found or it is found. So this is how this array is linked. Now, let me run it so that we can put some names and check for ourselves. I'm running. I just click here. Okay, that's good. We have, these are the unsorted inhabitants. We know this already done the other day. Sorted names of the inhabitants. You see that they are sorted. Now enter the name to search. Somebody should tell me, which name should I search?
Gary.
Larry. Is there Larry there?
Gary. Gary. With
Okay, Gary. This one. So I have Gary. See, name is found at position 5, and the name is Gary. So let us count. 1, 2, 3, 4, 5. Is it true? It's true. Now let us put a name that is not found on the list. Just put a name that's not found in this. You see, name not found,
Uh,
name not found. So let us go back to our question to now finish it. Okay, the question now says, modify your main program in three, so that it calls a select sort procedure. Then prompt for a name that it uses to call the procedure binary search with. It's already done. They're asking us to modify our program so that we can be able to call the selection sort, which was already done. And then save your program code as tax2a, bring a copy of it, also screen capture a copy of your output as bring out 2b, then print it. That's not a problem to us. Run your program from 4, but enter a name that is not found in the array of names. Screenshot or screen capture and save your output as bring out 2c, and then print it. We have already done it. We have tested with a name that is not found in the list, and we see that we saw that everything was okay. Then use your output from 5. Now this is 8 and 9 to justify whether or not the program implemented is correct. So to me, the program is correctly implemented because we enter a name that is found in the array of string, and we're able to see the name. We were able to find the name at a certain position. Then we equally enter a name that's not found in this list of inhabitants, and our program was able to tell us that the name does not exist. So that is our justification that our program is apt. So that is it.